Hello friends, continuing with the topic of junction diode in electronic devices. Today we come to its next part, applications of diode. There are many applications of diode like rectifier, switch, gate, peak clipper, power protector, radio detector, and variety of diodes are used for many other applications also. Like photodiode is used as optical detector, LED and laser diodes are used as optical source, display devices, etc. etc. Apart from this, other diodes are also there like Zener diode, which can be used as voltage regulator, tunnel diode, which can be used as microwave oscillator, hot carrier diode, pin diode, and so many other diodes are also there. All are p-n junction diodes. Basically, all are p-n junction diodes. Now, application of diode as rectifier. Now, what is rectifier? Rectifier is a device that converts AC into DC. Now, for example, look at this block. This block is a rectifier having AC at its input and DC at its output. This type of rectifier, we call it as half wave rectifier because positive halves are present at the output. Negative halves are absent. So we say it is half wave rectifier because we get half wave at the output side. Now look at this block. This block also represents a rectifier where input is as AC and output is DC. In output, both the halves are present, positive halves as well as negative halves are present in the output. So we say it is full wave rectifier. Okay. So input AC is same, but output in this part we have half waves, that is positive peaks, and here we have full wave, that is positive as well as negative peaks at the output. So we call it as full wave rectifier. Now two types of rectifiers as we have discussed above. First is half wave rectifier, second is full wave rectifier. Now we are to take up one by one. First we will take up half wave rectifier and explain how rectification takes place. Then we will take up full wave rectifier and we will explain how rectification takes place. Now first we take up half wave rectifier. Now how we define half wave rectifier? When only either positive halves or negative halves of the AC cycle are present at the output. When AC is applied at the input, the kind of rectifier is known as half wave rectifier. I repeat, when only either positive halves or negative halves of the AC cycle are present at the output, the kind of rectifier is known as half wave rectifier. So here you can see this is the block diagram of half wave rectifier where we have AC at the input and we have half wave, that is positive peaks at the output. So it is half wave rectifier. Now full wave rectifier. Let us define full wave rectifier. When both the halves of AC input are present at the output along same direction, the kind of rectifier is known as full wave rectifier. I repeat, when both the halves of AC input are present at the output along same direction, the kind of rectifier is known as full wave rectifier. Now here you look at this block diagram of full wave rectifier. This is AC input and this is DC output. At output we have both the halves, positive halves as well as negative halves. So it is a full wave rectifier. Now let us take up half wave rectifier using semiconductor diode. Now how semiconductor diode can be used as a half wave rectifier, let us see. First we draw the circuit. This is the circuit diagram for half wave rectification using semiconductor diode. Now let us look at the components of the circuit. T is a step down transformer. D1 is rectifier diode. RL is load resistance across which output is taken. C dash is electrolytic capacitor which removes AC ripples and smoothens DC. AC input is applied across primary AB of the transformer and output is taken across load resistance RL. Function. How rectification takes place. Let us see. In two steps we will study the function. First we will apply forward bias to diode D1, then we will apply reverse bias to diode D1. Now how we apply forward bias to diode D1? Let us see. Now negative half at input of transformer, this negative half, and positive half at input of diode, this positive half at input of diode D1. Now suppose at any instant of time A is negative, B is positive, this positive, then C will be positive, this C will be positive, this positive, and D will be negative, this D will be negative. In this situation, forward bias is applied to diode D1 and it conducts. You know, under forward bias conditions the diode conducts. So in this situation D1 conducts. Current flows through load resistance RL and output is available across it. It refers to this peak and this peak. Okay. Now reverse bias applied to diode D1, positive half at input of transformer and negative half at input of diode. So this is the second stage for explanation of rectification when reverse bias is applied to diode D1. During next half, A is positive and B is negative. Then C will be negative and D will be positive. Thus, reverse bias is applied to diode D1 and it does not conduct. No current flows through load resistance RL. Now, there is no current through this resistance and output is not available across it. Now, this situation refers to this negative half and this gap. So this process repeats and positive peaks of input at diode are available at output. Negative peaks at input of diode are absent from output. Okay. Thus positive peaks are available at these positive peaks are available. This process repeats and positive peaks of input at diode are available at output and negative peaks at input of diode are absent from output. Now input of diode and input of primary. The voltage across secondary is input of diode and voltage across primary is input of transformer. Now both are 180 degree out of phase as we know in transformer. So the primary and secondary voltages are 180 degree out of phase. That if A is positive, C is negative. Okay. If B is positive, D is negative. If B is negative, D is positive. So this is 180 degree phase shift between primary and secondary. So here we are talking of input of diode, whereas we are applying AC input at transformer. So this confusion should not be there. When there is a negative half at the primary, then there will be positive half at the input of diode. Okay. So this is how you are to make it clear. Now let us discuss output of the rectifier. Output of the rectifier contains DC as well as AC ripples. I repeat, output of half wave rectifier contains DC as well as AC ripples. The frequency of AC ripples is equal to frequency of input AC. Now this is the output of half wave rectifier, which contains DC as well as AC ripples. Now function of capacitor C dash. C dash minimize AC ripples up to some extent and smoothens DC output. I repeat, C dash minimizes AC ripples up to some extent and smoothens DC output. So this is the DC output after connecting C dash. Now how it smoothens DC? Now C dash charges during every positive peak available at output and discharges during the gap period, thereby giving an output during gap times as shown in diagram. So this is the gap period where also we get some output. Finally, after C dash we get DC output as shown in this diagram. Okay, it still contains some ripples. Further, by using good quality filters, perfect DC can be obtained. So this is AC input and this is perfect DC or pure DC we have, where we have the constant amplitude. The remaining ripples in this output are also removed by using good quality filters. So this is how we get half wave rectified output. After learning about half wave rectification using semiconductor diode, now we come to full wave rectifier using semiconductor diode. The circuit. Look at this circuit. T is a step down center taped transformer. So this is center tape transformer. So this is the center tape at C1. The secondary has 3 terminals, whereas primary has 2 terminals. For full wave rectifier, we need a transformer with 5 terminals with electrical center tape C1 at secondary. D1 and D2 are rectifier diodes. So this is D1 and this is D2, which are rectifier diode. RL is load resistance across which output is taken. C dash is electrolytic capacitor which removes AC ripples and smoothens DC. AC input is applied across primary AB of the transformer and output is taken across load resistance RL. Okay. Now function. Function means how rectification takes place. We have to look into it. Now in that there are two cases where we will describe the function. First, under forward bias applied to diode D1 and reverse to D2, and then reverse bias applied to diode D1 and forward to D2. Now first we take up the first case, forward bias applied to diode D1 and reverse to D2. Now how it is applied, let us look into. The situation is when negative half at input of transformer and positive half at input of diode D1 and negative half at input of diode D2. Now suppose at any instant of time A is negative, A is negative, B is positive, then C will be positive and D will be negative. Thus forward bias is applied to diode D1. Then C1 will be negative with respect to C and C1 will be positive with respect to D. Thus forward bias is applied to diode D1 with respect to center tape C1 and it conducts. Current flows through load resistance RL along XY direction and output is available across it. Diode D2 is reverse biased with respect to center tape C1 and does not conduct. So therefore no current flows through RL due to diode D2. Now let us take up the second case of reverse bias applied to diode D1 and forward to D2. What is the situation? Positive half at input of transformer and negative half at input of diode D1 and positive half at D2. So this is the situation where we are to explain. Now during next half A is positive, this is positive, B is negative, this is negative, then C will be negative and D will be positive. Now polarity signs are placed on the outside of the transformer. Thus reverse bias is applied to diode D1 with respect to center tape C1 and it does not conduct. Diode D2 is forward bias with respect to center tape C1 and conducts. Now current flows through load resistance RL again along XY direction and output is available across it of same polarity. Now this process repeats at both the peaks of input AC at diode are available at output. I repeat, this process repeats and both the peaks of input AC at diode are available at output. One through conduction of D1 and the other through conduction of D2. Thus full wave rectification takes place. At the output we get both the halves placed at input of the circuit. Now let us discuss about output. Output contains DC as well as AC ripples. Now frequency of AC ripples is equal to twice the frequency of input AC. Now function of capacitor C dash. C dash minimizes AC ripples up to some extent and smoothens DC output. This is the output of rectifier which contains AC ripples. Now how AC ripples are removed by C dash? C dash charges during every positive peak available at output and discharges during the gap period, thereby giving an output during gaps time as shown in diagram. And finally we have the output DC which still contains little bit AC ripples. And finally we get DC output which is shown in this diagram. Further, by using good quality filters, perfect DC can be obtained. This is AC input. After using good quality filters, we can get perfect DC. Okay, this is how a full wave rectifier works. Now assignment 14 continued. Question number 32. Draw a circuit diagram of a full wave rectifier. Explain its working principle. Draw the input-output waveforms indicating clearly the functions of the two diodes used. Question number 33. Draw a labeled circuit diagram of a full wave rectifier and briefly explain the working principle. Question number 34. Explain number 1 forward biasing, number 2 reverse biasing of a PN junction diode. With the help of circuit diagram, explain the use of this device as half wave rectifier. Question number 35. Explain the function of capacitor connected across the load resistance. Question number 36. The frequency of AC input to a rectifier is 50 Hz. What is the ripple frequency of output in case of half wave rectifier, second full wave rectifier? Thank you so much. Next time we will take up some special diodes like Zener diode, photodiode, light emitting diode, laser diode and solar cell, etc. Till then, goodbye and good luck to you.